Okay, for this one we'll first of all start off using the quotient property, that the log of a quotient is the difference of the logs. So we'll write this as the log to the base b of the numerator, which is the cube root of a times the square root of c, minus the log base b of the denominator, which is the square root of a times the cube root of c. We can then write each of those radicals in fractional exponent notation, and that's a to the 1/3 power times c to the 1/2 power. And similarly over here you have a to the 1/2 power and c to the 1/3 power. And now we have a product here and a product here. So we use the property that the log of a product is the sum of the logs for each of these. And we get the log to the base b of a to the 1/3 power plus the log base b of c to the 1/2 power minus, over here, the log base b of a to the 1/2 power times plus the log base b of c to the 1/3 power. Now we use the property of logs, that a log of something to a power is the product of that coefficient times the log. So we pull down each of the coefficients here, and we get 1/3 the log base b of a plus 1/2 the log base b of c minus 1/2 the log base b of a minus, because we distribute this negative also, 1/3 times the log base b of c. And finally, we can substitute in the values they gave us for each of those quantities. So we get 1/3 of log base b of a, which is 4. So 1/3 times 4 plus 1/2 times the log base b of c, which is negative 5, minus 1/2 the log base b of a is 4 again, minus 1/3 the log base b of c, which is negative 5. So we end up having 4/3 minus 5/2 minus 2 goes for minus 2 and plus 5/3. So this all adds up to 4/3 plus 5/3 adds up to 9/3, and negative 5/2 minus 4/2 is minus 9/2. Now this is equal to 3 then, minus 9/2. Or if we convert to finding a common denominator and all that business, 3 times 2 divided by 2 is 6/2 minus 9/2. 6/2 minus 9/2 is minus 3/2. So that's our answer for this, negative 3/2. That's what this expression simplifies down to.